China's concrete that heals its own cracks. Engineers are calling it the end of repairs. Somewhere in a lab outside Beijing, there is a slab of concrete with a crack running straight through it. Nobody has touched it, patched it, or poured anything on top of it. And in 14 days, that crack is gone. Not covered, not painted over. Gone, sealed shut by the material itself, as if the concrete simply decided to heal. That sentence sounds like something out of science fiction, but it is happening right now, and it is about to solve a problem that costs the world hundreds of billions of dollars every single year. Every bridge, every parking garage, every high-rise you have ever walked into is quietly cracking from the day it is built. Water gets in, steel rusts, cracks spread, and engineers spend a staggering amount of money every year just chasing those cracks around, patching them before they become structural failures. In the United States alone, the annual bill for concrete repair and maintenance runs past $100 billion. Globally, it is closer to $1 trillion. That is not new construction. That is just fixing what is already standing. So when a materials science team in China published results showing concrete that seals its own cracks without a single human touching it, the engineering world did not just take notice. It started scrambling. If you like videos about breakthroughs quietly rewriting entire industries, hit like and subscribe so you do not miss what is coming, because this story gets stranger the deeper you go. Why nobody fixed this sooner? Concrete cracking is not a defect. It is baked into the physics of the material. Concrete is strong under compression, meaning it holds up incredibly well when you push down on it. But it is weak under tension, meaning it resists being pulled apart far less effectively. Every building sways slightly in the wind. Every bridge deck flexes under traffic. Every slab expands and contracts with temperature. All of that tiny, constant movement creates hairline cracks almost from day one, and engineers have known this for over a century. For decades, the fix was always reactive. Inspectors walk bridges looking for cracks. Crews inject epoxy resin into gaps by hand. Entire departments exist inside transportation agencies purely to hunt for damage before it becomes dangerous. Some researchers tried building in redundancy, extra steel reinforcement designed to carry load even after cracking starts. Others experimented with special coatings meant to slow water intrusion. None of it addressed the actual problem, which is that once a crack starts, water and chemicals have a direct highway straight to the steel reinforcement inside, and that is where real structural damage begins. The bacteria hiding inside the concrete. The breakthrough came from a research group working across Southeast University in Nanjing and the China Building Materials Academy. And the core idea sounds more like biology than construction. Inside the concrete mix, researchers embedded microcapsules containing dormant bacterial spores, a specific limestone-producing species that can survive the harsh alkaline environment inside cured concrete for years without any oxygen or water. Alongside the spores, they packed in a food source, calcium lactate, sealed inside the same tiny capsules. For the entire life of the structure, those capsules sit completely inactive. They do nothing. They are simply along for the ride. But the moment a crack opens up, water and air finally reach the capsules for the first time, and that exposure triggers something remarkable. The dormant bacteria wake up, start feeding on the calcium lactate, and as a byproduct of that feeding process, they produce calcium carbonate, which is essentially limestone. That limestone crystallizes directly inside the crack, filling it from the inside out until the gap is physically sealed. In lab trials, cracks up to 0.8 of a millimeter wide, roughly the thickness of a credit card, closed completely within 2 to 3 weeks. Compressive strength in the healed sections returned to nearly 90% of the original uncracked concrete. And here is the part that made engineers sit up. This is not a coating applied after the fact. It is built directly into the concrete mix from the very beginning, meaning every single crack that ever forms across the entire lifespan of the structure triggers its own repair automatically, without an inspector, a work order, or a repair crew ever getting involved. The team published their full methodology openly, including microscopy images showing the mineral formation inside sealed cracks and compression test data comparing healed and unhealed samples side by side. That transparency mattered because self-healing concrete had been theorized for over a decade in various forms. What changed here was proof that it actually worked reliably outside a laboratory, at a cost low enough to make sense for real construction budgets. The world starts paying attention. Word moved fast once the data became public. Within a year, engineering firms in the Netherlands, a country that had been experimenting with early bioconcrete formulas since the early 2010s, began adapting the Chinese bacterial strain and capsule design for coastal infrastructure projects, where saltwater intrusion makes crack damage especially expensive. A German research consortium ran trials embedding the technology into tunnel linings, where repair access is difficult and expensive by nature. In Singapore, where land is scarce and buildings are pushed to last far longer than average, a state infrastructure agency began piloting the material on pedestrian bridges specifically chosen because they see constant vibration and flex from foot traffic. Insurance and infrastructure financing groups took notice for a different reason entirely. Self-healing concrete does not just save on repair labor. It extends the realistic lifespan of a structure, which changes the entire financial math behind large infrastructure projects. A bridge rated to reliably last 100 years instead of 60 is a different investment altogether, and several sovereign infrastructure funds have already started asking contractors whether self-healing formulations are available for upcoming bids. None of this is happening because of environmental branding or a feel-good story. It is happening because the economics are brutally simple. Reducing lifetime repair costs by even a modest percentage across a portfolio of thousands of bridges and buildings adds up to real money extremely fast. How big could this actually get? If self-healing concrete were adopted across even a third of new infrastructure projects globally over the next 2 decades, researchers estimate the cumulative savings in repair and maintenance costs could run into the hundreds of billions of dollars, alongside a meaningful drop in the raw material and energy needed to manufacture replacement concrete for repairs that simply never happen. But it is worth being honest about the road ahead. Building codes move slowly, and any material this new needs years of real-world monitoring before regulators fully trust it in load-bearing structures. The bacterial capsules also add cost to the initial concrete mix, so the savings only materialize over a building's full lifespan, which makes it a harder sell for developers focused purely on upfront construction budgets. And questions remain about how the technology performs in extreme cold climates, where bacterial activity slows dramatically, something researchers are actively testing right now. Those are real hurdles, not small print. But for the first time, concrete that repairs itself is not a laboratory curiosity. It is sitting in real bridges, real tunnels, and real pedestrian walkways today, quietly closing cracks that would have cost someone, somewhere, a repair crew, and a bill. If this changed how you think about the buildings around you, hit like and subscribe for more stories about technology quietly rewriting entire industries. And tell me in the comments, if concrete can heal itself, what other everyday material do you think is hiding a breakthrough nobody has noticed yet?